Topic focuses on the validation of value at risk VaR models, which is a critical process for ensuring that market risk estimates are accurate, reliable, and appropriate for institutional risk management objectives. VaR model validation examines whether the assumptions, methodologies, inputs, and outputs of a model are conceptually sound and statistically robust. Since banks rely heavily on VaR estimates for trading limits, regulatory capital, and strategic decision-making, weaknesses in model design can expose institutions to severe financial losses. The program emphasizes that model validation is not a one-time exercise, but an ongoing process involving backtesting, sensitivity analysis, benchmarking, and continuous review of changing market conditions. One of the primary components of VaR model validation is assessing conceptual soundness. A model must align with the institution's specific risk management objectives and accurately represent the risks embedded within the portfolio. Validation teams evaluate assumptions regarding return distributions, correlations, volatility behavior, and liquidity conditions. Incorrect assumptions, such as relying excessively on normal distributions during turbulent markets, may cause systematic underestimation of tail risk. The program highlights that effective validation requires understanding both the mathematical foundations of the model and the economic intuition behind its application. Validators must therefore determine whether the model structure remains appropriate under changing market environments and portfolio compositions. The topic also discusses the importance of confidence intervals and statistical precision in VaR estimation. Confidence intervals measure the range within which the true VaR estimate is expected to fall with a specified probability. However, calculating these intervals presents challenges because financial returns often exhibit skewness, fat tails, and volatility clustering rather than normal behavior. The program explains that inaccurate or incomplete historical data can further reduce the reliability of VaR confidence intervals. Non-parametric approaches, such as bootstrap methods and order statistics, are frequently used to estimate the distribution of VaR outcomes more effectively. During periods of market stress, confidence intervals widen considerably, reflecting increased uncertainty in market risk estimation. Benchmarking is another essential validation technique discussed in the topic. Benchmarking compares the institution's VaR model against alternative models or realized profit and loss outcomes to evaluate relative performance and predictive accuracy. For example, banks may compare positional VaR models with GRCH-based VaR estimates derived from historical trading results. The program notes that benchmarking is difficult because trading portfolios evolve continuously and maintaining multiple independent models can be resource-intensive. Furthermore, statistical comparisons between models may be complicated by non-independent error structures. Despite these limitations, benchmarking remains valuable because it identifies whether a model is consistently too conservative or insufficiently sensitive to changing market risks and volatility conditions. The program concludes that successful VaR model validation requires combining quantitative analysis with professional judgment and strong governance practices. No model can perfectly predict future market behavior, especially during periods of financial instability, structural change, or systemic crisis. Therefore, institutions must supplement VaR validation with stress testing, scenario analysis, sensitivity testing, and ongoing model recalibration. Regulators also expect banks to maintain independent validation functions that regularly review methodologies, assumptions, and implementation procedures. Effective validation frameworks improve confidence in market risk estimates, strengthen capital adequacy assessment, and support regulatory compliance. Ultimately, VaR model validation enhances the resilience of financial institutions by ensuring that risk measurement systems remain credible, transparent, and responsive to evolving market dynamics.